Let's take a closer look at some of the tool resources that we're going to use that we have laid out on the table here. So we can start with measuring and marking. Measuring and marking is the one thing that is relatively easy to control if you have the right tools available. And for me, I would say that the combination square is probably my favorite tool for doing layout. If it's right angles that I'm looking at, and if it's a series of repeated marks of the same dimension, then I really like that combination square, because let's say, for example, that I've got my sheet measured out to the proper dimensions, and now I want to have a 2-inch lip that folds in all the way around the perimeter of my material. I can simply take my combination square, move it over to that 2-inch mark, butt that combination square up against the edge of my material, and strike a line with my scribe at that 2-inch position, and then rotate it to the corner and strike another line at my 2-inch position, and go all the way around to lay out my pattern for cutting. So the quality of your combination square doesn't need to be super high for a project like working with thin gauge sheet metal, but better quality tools are going to perform better. So I'd encourage you to add a combination square to your quiver of measuring and marking instruments. Proper scribe also gives us a nice, clean, sharp line to follow. If you're drawing with a crayon, it's going to be hard to have good, accurate lines. So I like laying out my marks with a Sharpie. On this side, I went ahead and I struck all the lines that I need for the perimeter. I marked a line through the areas that are my waist, and a dotted line along the areas where I'm going to make my folds. So let's set that aside for just a second and move on to shearing material. So if you've had success with a pair of scissors, you can be wildly successful with a pair of snips like these, or shears like these aviation snips. Yellow handles are engineered for making straight cuts, and will also do a slight curve at about a 2.5-inch radius. If you're doing tighter turns, then you'll benefit from using the green or red. Green cuts right and red cuts left, and that allows you to be able to cut a tighter circumference. But if we're making straight cuts, the important thing to understand is that unlike a piece of paper or a piece of fabric that you might cut with shears or scissors, when we're cutting sheet metal, there's always what we call a waste side and a save side. Save side is to the left, waste side is to the right. So what that means is that in reality is that the material on the right side is always going to be bent or deformed out of the way, and the material on the left side will stay flat. So as I start to cut through this material, you'll see on that right-hand side that the waste, or what I'm cutting away, is being deformed or pushed out of the way. When you're cutting through thin gauge sheet metal, it's important that you only use a portion of what we call the stroke of that cutting capacity, and never go to the very end of the cut, because when you go to the end of the cut, you'll notice that it will bend or deform that material in a way that is that's objectionable. So again, what we want to do is we want to just go deep and use about 3/4 of that capacity of the jaws as we advance forward. And as a side note, if you want to keep your aviation snips in good shape, don't ever cut wire with them. Some may be equipped with a wire cutter on the side of them, but these jaws are not designed for cutting wire. So let's just pull a little radius on this. So as I advance, I'm turning, and that allows me to cut away a radius. And again, the waste on the right is always the piece that's being deformed or pushed out of the way. Now, no matter how sharp your aviation snips are, you're still always going to have a little lip that hangs up on the bottom side of your material that may need to be removed with sandpaper or a file. And if you're cutting something like large circles, you'll find it hugely advantageous to have some material handling gloves like these on to minimize the risk of that what could be a very sharp edge cutting your hand. So let's move on from shearing to the practice of bending. These are called seaming pliers, and they have adjustable backstops on them to restrict how deep the material goes into the depth of the jaw. And so I can advance these or draw these back for whatever where my bend is to be. But I could also strike a line or make marks on either side and just line up with the two outer edges of my tool. And then I'm going to bring that to bear on a flat surface, just like this. So you've got to get a tight grip and advance forward. And that allows us to bend that edge over. Now remember that you always have to slightly over bend because of the phenomena of spring back that occurs in most of these sheet goods. Right? So seaming pliers. They also make a type of seaming plier that I don't have here with me, but looks like this, but has jaws like these seaming pliers, so it gives you this continuous surface. Sometimes they're referred to as duckbill locking pliers, and that allows you to be able to clamp onto a piece of material and again make bends in that piece of material. Now, the bends might not be as sharp as you want them to be, so one of the tricks that I use is that I will often come up to my edge like this and then hang that over the edge of a sturdy surface and then take a saw-faced hammer like this and that will make that bend a lot more crisp and sharp. Another way that you can increase the likelihood of your bend being nice and sharp is to take your combination square and a scribe and to take that piece of material and on the back side of the bend, take your scribe and strike across the surface of that material and score a line on the backside. And by scoring that line on the backside, let me just close this seam up. Roll this over so I can make that second bend. So now if I come in, it should break or bend along that line more readily because of that score that I put onto the backside. You see how much more precise that was? And I still might come in and just tap that down to sharpen that edge up, right? So back scoring like that can be a useful tool for making more precise bends in the material. We can also use the edge of an anvil to sharpen up a seam, and that can be done by using one of the hammers that I have laid out on the table here. So let's just do a quick review of some of those types of hammers and mallets. So here we have a wooden mallet. Mallets will almost always have the end grain as the working face of that mallet because end grain has more resistance to impact than does long grain. You You might also notice that the buck that I made to work against here is all end grain percenting itself up because, again, those fibers oriented up have a higher resistance to impact and compression. So we have a series of a couple of different types of dead blow hammers here. Dead blow hammers typically have a soft face on them, and the head of the hammer is either filled with steel shot or with sand, which gives it more inertia, and it also has a tendency to control impact by minimizing the rebound or the bounce back up to the surface of that material. These hammer faces can be attached in a number of different ways. There are some that are screw-on, like here and here. These faces are screwed on to the head and can be unscrewed and swapped out for new ones as they wear. There's also what are called split head hammers like this, that a nut is loosened and allows us to swap these out to different types of hammer heads that are of different densities. So if I'm doing really delicate soft work, I might want rubber, or if I want something that has higher impact, I might be using Delron or plastic or nylon or copper or rawhide or polyurethane or polyethylene hammer faces. And the big advantage of these types of hammers that have these plastic or soft faces is that they won't mar the material, and they reduce the thinning of the material, because if I hit it with a hard hammer, it spreads and thins that material. And that is going to affect both the appearance, and it's going to affect the degree to which that material thins when you work it over a hard metal edge, like on the edge of this anvil. So we're also looking at a couple of other different types of hammers here. I don't have a sample of a riveting or tinner's hammer here, which is used for driving and spreading rivets, but I have two examples of what are called setting hammers, or sometimes they're referred to as seaming hammers. And setting hammers or seaming hammers allow you to form corners and close seams. So when someone was working on the inside of a box like this, a setting or seaming hammer would let them come into a tight corner to clean up those corners to sharpen them up after forming. What else? Lest we forget, a whole bunch of different pliers. Some of these pliers may have some use for light gauge sheet metal work, but most of these pliers are engineered or designed for working with thin gauge rod or wire. So the classic being the needle nose. So this needle nose has a tapered nose. The idea behind a needle nose, it allows us to be able to bend different circumferences in the end of a wire. So if I'm holding it out towards the end, I get a loop that big. If I bring it a little bit deeper into the jaw like this, then I'm going to get a loop this big. So that gives us a wide range of, or I'm sorry, not a wide range, but a range of different loops that we can get. It also has these marks cut across the surface to increase the hold on that material when you're bending it, so it's less likely to slip or cam out. And then it also has a cutter located in it for shortening those lengths. So the big difference between these pliers and needle nose pliers is that the needle nose pliers do not move in parallel. As they open, they get further apart from each other. But these pliers move in parallel, which means that if we're holding on to a piece of sheet metal like this, it allows us to be able to grip it, distributing the load over all that surface area, as opposed to these pliers that come in at an angle where there would be a gap that would exist as you go further back on that pair of pliers. So some of these pliers, again, have smooth jaws so that they're non-marring, and they come in a range of sizes. Some have springs in them to minimize hand fatigue, like these guys, and some of them are radiused all the way around the nose of those particular pliers. So I hope this gives you a good idea or a better idea about some of the tools that we're going to be working with. And well, while we're still here, let's go ahead and look at what it's like to use these saw face hammers to roll an edge over on this. So as I mentioned before, we can come in and we can clean up and sharpen an edge across the edge of a bench anvil like this, but it could also be done over a piece of angle iron or any other piece of steel stock. So I have the rubber side, which absorbs more impact, the plastic side, which is less, and I can come along holding a flash and this will help sharpen up that bend a little bit, working across that clean edge. A bench vise or machinist vise can also be a useful tool for bending stock. And in many of the vices that you find out there, bench vices that you find out in the world, the jaws on those vices are replaceable. So you can actually unscrew the existing jaws and screw on pieces of bar stock that are longer for bending wider sheets of material. So all of the bends for this little copper airplane were all done in a vise similar to this. But let's just look at what it's like to bend that piece of material over an edge like this. So I'm always going to want to put it in a little tension and pull down on it just a little bit, and then start to coax or drive that material down. If my vise jaws are not wide enough and I can't extend those vise jaws, then I can simply unlock and now slide it to this corner and tap that down a little bit more, and then slide to the opposing corner and tap that down a little bit more. But you're never going to be able to get a 90-degree bend in a vise like this, because anytime you bend sheet metal, it always has a little bit of what we call spring back, where it bounces back a little bit. So because we have the need to overbend the material slightly so it'll return to the position that we want it in, we're not always going to hit that exactly at 90, but we can come back in, again, working over a sharp edge and drive that down a little bit further and sharpen that edge up. If you didn't have a vise available to work with, then you could get away with using a couple pieces of good grade of plywood like this Baltic birch, a C-clamp to hold those two pieces of plywood together, and then I can just start on my end and work my way down. And clean and sharpen up that seam. Now, I typically like to use a C-clamp, and although I like quick clamps for a lot of operations, I don't like using quick clamps anywhere there's a lot of vibration, like where we're hammering, because they tend to loosen up because of that hammering.